All right, good morning, folks. On Friday, we talked about putting functions together using the operations of addition, subtraction, multiplication, and division. Today, we're going to move forward with that and continue our discussion of putting functions together. But today, we're going to do something called function composition. And what function composition really is, it's where one function will plug into another and then simplify. So I think about this almost like a function within a function. So again, a way to think about this as a function within a function. The notation that we're going to use to represent composition is this open circle. And that's why on Friday I said be very careful when you're multiplying and make sure that you are using that filled in circle to represent multiplication, which is not to be confused with the open circle, which represents composition. Now, the way that we're going to notate this is in one of two ways. You can either notate it using what's sometimes called the FOG function, f of g of x. That I just highlighted in yellow is exactly the same thing as if we use the parentheses notation, f of g of x. The way that we say that is f of g of x. And that would be regardless of whether you're using the FOG notation or the parentheses notation. I really like and prefer the parentheses notation, and I'm going to explain why when we get to the top of the next page, but you are welcome and able to use either of them. They really both mean the same thing. All right, at this point, I'm going to head up to the top of page 30. You're going to want to also I'm going to zip through these relatively quickly. If I'm going too fast, please feel free to stop the video, pause it, rewind it. But I'm just doing this in with a thought in my mind that I'm trying to do the video and make the video as efficient as possible. So up at the top of page 30 now, it says, given these three functions, f of x equals 2x minus 3, g of x equals 1 over x minus 2, and h of x equals x squared plus 2. They want us to perform the composition and state the domain. I'm going to ignore the domain for the time being because that's the more complicated piece of this, and I really want to focus on being able to perform the composition. Notice that all of these on page 30 are written in that FOG notation. I'm going to rewrite using my parentheses because I think that's easier to follow and it just makes more sense in my mind as to how I'm going to proceed with the problem. So this g of f of 2, I'm really going to rewrite using the parentheses, and that becomes g of f of 2. Here's why I like the parentheses, because as mathematicians, we all know that we need to start in parentheses first. So when this function or when this composition is written using the parentheses, it becomes pretty clear to me that my starting point here is going to be to go ahead and to find f of 2. So that's exactly where I'm going to begin this composition. I'm going to start by finding f of 2, or by substituting 2 into my f of x function. So that becomes 2 times 2 subtract 3, or 4 minus 3, which is 1. So now the value of this f of 2 is 1. So my next step now would be to go and find g of 1. So this time I'm going to use my g of x function, and I'm going to replace any x that I see in that function with a 1. So this becomes 1 over 1 subtract 2, or 1 over minus 1, which will simplify to minus 1. So g of f of 2 has a value of minus 1. Ordinarily, I would stop here and say if anybody has questions, now would be a good time to ask. I'm not here to do that today, but Mrs. Black and Mr. Correa would be good people to ask if you have a question at this point. I'm going to shoot on to number 5. And again, I'm going to rewrite this using my parentheses notation. This says to find f of g of -1. And again, once I write it in this format, mathematicians always start within the parentheses, so that tells me that my starting place for this composition is going to be to go and find g of -1. So g of -1, when I substitute or plug -1 into the g of x function, it becomes 1 over -1 subtract 2, which is 1 over -3 or -1/3. So again, now I know that this highlighted piece of it has a value that's -1/3. My last step is to go evaluate or find the value of f of -1/3. So that would become 2 times -1/3 subtract 3. If it helps you, put that 2 over 1, because now I'm going to multiply numerators together to get -2, multiply denominators together to get 3. So there was your very brief, very quick rehash on multiplying fractions without the use of the calculator. From that, I want to subtract 3, but I notice that the numerator of my first fraction is a 3, so I'm going to rewrite that as -9/3. 9/3 and 3 have the same exact value, but the 9/3 now will allow me to go and combine those fractions due to the fact that I now have a common denominator. And when I combine those fractions, I end up with -11/3. So now we have not only composition of functions, but we have some fractions thrown in there. These are some really good times. Again, at this point, I would pause and ask if anyone has questions. I'm going to say pause, and if you have questions, now would be a good time to ask Mrs. Black or Mr. Correa. Number 6 says find h of f of 0. So again, my goal here, my mission, I'm going to rewrite this using parentheses, because now I can see that I want to begin by finding f of 0. So f of 0 would be 2 times 0 subtract 3, or 0 subtract 3, which is -3. Now I'm going to go plug that -3 in place of the f of 0, so it becomes h of -3. And h of -3 says to do -3 and square it and add 2. So that becomes 9 plus 2, or 11. Again, if you have questions, now's a great time to pause the video and ask Mrs. Black or Mr. Correa. I'm going to boogie right on past number 7 so that I can talk about, instead of plugging numbers into functions and evaluating numbers, I can substitute functions into functions, which is really the meat and potatoes, or the biggest part of this lesson on composition. All right, so let me scroll down. And again, the really important piece of this is numbers 8 through 13. In the interest of time, I think we will only talk about a few of them, because I would rather do a few of them well than try to hurry to get all of them done and not really do any of them any justice. So in this part of the exercises, we are given 3 functions, and again, we want to perform the composition and state the domain. Notice that what we're performing the composition on here is not a number like it was up above in numbers 4, 5, and 6, but rather on x. And this is why we're going to be substituting or plugging a function into the function. Because we are going to work domain for these questions, I'm going to think about the domain of each of the original functions. My f of x is a parabola. Its domain is going to be all real numbers. I think I'm going to put this kind of off to the side to squeeze it in. I'm going to ignore the domain for g of x for the time being and scoot over to h of x. H of x, 4 minus x, or negative x plus 4, is a linear function. It too will have a domain that's all real numbers. But g of x is where the domain really gets fun. G of x, we have that radical, and we know that our radicand that lives underneath the radical can't be negative. That x minus 6 has to be greater than or equal to 0. And that tells us that our x values have to be greater than or equal to 6, which tells me that for g of x, the domain starts at and includes 6 and goes to infinity. So again, that middle function really has the most interesting domain here. This is going to be important as we move forward through these because I think that this is super tricky and we have to follow this restriction and follow the domain all the way through the composition of the functions. Now, like the examples that I did up above, I want to start by rewriting this using parentheses notation. So I'm going to make this say f, and I think I'm going to go underneath here. I wish we had more room to work, but we're going to do the best that we can with what we have to work with. So this says take f of the function g of x. And just like up above, we did some substitution with numbers. Here too, we're going to do some substitution, but this time we're going to substitute or plug in the function. So my function g of x is the square root of x minus 6. So all I'm going to do here is I'm going to start in the parentheses once again, but instead of having a number to plug in here, I now have a function. So this becomes f of the square root of x minus 6. So now I'm going to evaluate the square root of x minus 6 in my function f. So my function f, or the f of the square root of x minus 6, well, that says take my x value, or take my input, and square it. Well, my input is the square root of x minus 6, and we want to square it. So when we square a square root, they disappear, and we're left with x minus 6. All right, so that is the easy piece of this. The hard piece of this is the domain. And what makes this tricky is that we have to consider domain for both the input and the output. The output here is the x minus 6. That's pretty simple. We all know that the domain of that line is going to be all real numbers. But what's tricky here is that we also have to take into consideration the input, and the input had some restrictions on it because the input was that square root function. And we said that his domain was 6 to infinity. So the restrictions on the input here are 6 to infinity. And a way to think about that is that anything you input or put into that function is going to follow all the way down through to the very end. So that even though the function at the end might not have any restrictions, the restrictions of the input are going to carry down or trickle down right into your final answer. So let me label that with a D for domain. So when we're doing these, we have to be really careful to consider both the domain of the function that we're inputting as well as the domain of what comes out, that composed function. These are definitely tricky. If you have questions about them, please ask when I come back. It really does, these are going to take us a while. Domain is by no stretch of the imagination easy or for the faint of heart. All right, so with that said, I'm going to go ahead and tackle number 9. Number 9 says find f of x, or find f composed with f of x. And again, I really like my parentheses for this, so I'm going to rewrite this as f of x. And again, big idea for today, start within those parentheses. So we're trying to find f of, well, f of x is x squared. So we're trying to find f of x squared. So what I'm going to do is take that x squared and go replace x with it in my f of x function. So f of x squared really means to take x squared and square it. And x squared squared is x to the fourth. And now I have to think about my domain restrictions. I have to consider my domain restrictions on my input. Well, my input was that x squared, whose domain was the all real numbers with no restrictions. So I like that. The output was x to the fourth, again with no restrictions. So no restrictions on the input, no restrictions on the output or the resulting function, mean no restrictions on our domain here, negative infinity to infinity. All right, I am moving on to number 10. This says find h of f of x. So again, I'm going to go for writing this with my parentheses. When I start in the parentheses, my f of x function is x squared. So this tells me to go find h of x squared. So I'm going to go to my h function, and anywhere in my h function I see an x, I'm going to replace it with x squared. So that becomes 4, instead of subtract x squared. So now is the point in time when I have to consider those domain restrictions. My input function is the x squared. It has no restrictions on it. My output, or the result of my composition, is the 4 minus x squared. It has no domain restrictions. And since both of those have all real numbers for their domains, so too will their composition. All right. Just for giggles, I want to go take a look at number 11, because notice that 11 is very similar to number 10. The only difference here is the order. So I'm kind of curious now to see whether the answer for number 11 is going to come out the same as the answer for number 10. So I've got f of h of x. And again, I'm going to start with the parentheses. So I'm going to replace h of x with the function. And h of x was 4 minus x. So now I'm going to go to my f function, and anywhere I see an x, I'm going to replace it with a 4 minus x. So f of x says to take our number and square it. So we're going to take our 4 minus x and square it. So this is going to be 4 minus x times 4 minus x. If you want to put that in standard form, you are more than welcome to put it in standard form. In the interest of time, I'm not going to. I want to consider domain restrictions. And again, I have to look at the input function. The input function was 4 minus x. No restrictions on that. The output function, again, is a parabola. No restrictions on that. making this my favorite domain of all real numbers. Notice that the answer I got for number 11 and the answer I got for number 10, not the same. So what that tells us is that the order in which we perform the composition matters. It matters. And I think in the interest of time, I'm not going to look at any more examples. We might take a look at 12 or 13 when I come back on Tuesday. But for the time being, I'm just going to add this important note about domain with composition down below. And I think then at that point, we're going to call it a day. I'm going to say that when you're doing domain with composition, make sure that you consider or state right along with the domain of the compose function, which is your output. So you really have to take into consideration both of those pieces when you're doing the domain of the composition. You have to think about the function that you're inputting it and its domain, as well as what's coming out as a result of that composition. Anytime you have an input function, the domain of that input function will follow all the way through the composition. All right, and at this point, I think I've said my piece with respect to inputs and outputs and domains and following through. I'm going to let you know that if you understand everything I talked about in the video, you're way, way, way beyond where I was in high school. This is really tough stuff. So if you have questions, I don't want you feeling badly about yourself or putting yourself down. Write them down. We will definitely have some time when I return on Tuesday. The content that we're slated to look at for tomorrow's lesson, significantly easier than this composition of functions. So we will have some time on Tuesday to revisit any questions that you might have had about this video. All right, I have some homework questions from you from the textbook pages, which I loaded into Teams also. Again, these are going to be a challenge. We're going to do our best to get them right. But again, with the understanding, with the knowledge that the work is difficult and it's demanding, and if you have questions, it's definitely okay to wait, and I will expect questions when I come back tomorrow. All right, folks, I don't tell you nearly as often as I should, but thank you for being you and for all of your hard work. Please continue to work hard and try your hardest at those domain questions on the textbook pages. But again, just know that I'll be there for you to clear up any questions, any misunderstandings, anything that needs clarification when I come back on Tuesday. All right, till then, take care, and I will see you Tuesday.